Hi folks, this video covers examples of integration. The first example here asks us to determine the integral of 1 over 2x cubed minus x to the 4 plus x to the 1/3 dx. What I will do with this question is I will separate them into pieces. So I'm going to write 1 over 2x cubed dx minus integral of x to the 4 dx plus integral of x 1 over to the 1 over 3 dx. After this, I will get 1 over 2x to the 4 over 4 plus c, let's call this c1, minus x to the 5 over 5 plus c2 and plus x, and here in all of them, all I'm doing is adding 1 to the exponent and dividing the whole thing by the exponent plus 1. So here 1 over 3 plus 1 gives me 4 over 3, and I'm dividing this by 4 over 3 as well, and plus c3. And when I add all these constants, I will just get one value, so one constant at the end. So instead of writing c1, c2, and c3, I'm just going to write c, and I will simplify things a little bit as well to clean things up. So x to the 4 over 8 minus x5 over 5 plus, and here just for the denominator here is 4 over 3, so I can change this to 3 over 4 x to the 4 over 3. So this becomes 3 over 4 x to the 4 over 3 plus a constant value of c. For this part here, I'm going to do the same thing. I'm going to separate it first, and I get 5 integral of ex, and note that I can bring the constant out of the integral sign, and that's what I did here. I write 5 and then I write integral of e to the x, and that will make my integration a little bit easier as I keep going. So plus 1 over 3 integral of x cubed, and I forgot a dx here, so I'm going to erase this for a second and add my dx, plus 1 over 3 integral of x cubed dx minus 4 over, well, just 4 integral of 1 over x dx. And then I'm going to use the rules of integration to find the integrals here. So I'm going to get 5e to the x plus c plus 1 over 3 x to the 4 over 4 plus another constant, so let's label this c2, minus 4 ln of x plus c3. Finally, I will simplify a little bit, and I will get 5e to the x plus 1 over 12 x to the 4 minus 4 ln of x, and I will add that to one constant, so c1 plus c2 plus c3, I'm just changing them to one constant. For this question here, it says integrate with respect to x. So the first one here, it says x times x minus 1 over 3 plus cos of x. And what I will do is, first thing I will do is I will expand the numerator here, and I will get x squared minus x over 3 plus cos of x, and I can simplify that and say it's x squared over 3 minus x over 3 plus cos of x. So now I want to find the integral of x squared over 3 minus x over 3 plus cos of x with respect to x. Alright, so now I'm going to separate these. So I will get equals to 1 over 3 integral of x squared dx minus 1 over 3 integral of x dx plus integral of cos x dx. And note that I took all of the constants out of my integral sign so that my integrating later becomes a little bit easier. So now integrating this gives me 1 over 3 x cubed over 3 plus first constant minus 1 over 3 x squared over 2 plus my second constant, and finally plus sine of x plus my third constant. And simplifying everything, I get x cubed over 9 minus x squared over 6 plus sine x plus 1 constant value, which is a combination of C1, C2, and C3. Now for the next part of the question, I'm trying to find the integral of negative sine x plus 2x to the 1 over 2 with respect to dx. And first thing I'm going to do is separate everything. So I get negative sine x dx plus 2x 1 over 2 dx. And what I've done is I have taken out the constants from the integral to make my integration easier. So now I get negative cosine of x plus c plus 2 times x to the 3 over 2 over 3 over 2 plus c. So I'm going to label this C1 and this C2. Now I'm going to combine C1 and C2 into C, and I get negative times a negative is positive, so I get cosine of x plus, and I'm going to take care of the denominator here. I have 3 over 2, so the 2 can come up here and multiply by 2, and the 3 remains here, and I get 4 over 3x 3 over 2 plus c. Okay, for this question we're trying to determine the integral of x squared plus x minus 3 over x with respect to dx. So what I will do first is I will separate this into x squared over x plus x over x minus 3 over x dx. And then I will simplify it as x plus 1 minus 3 over x with respect to dx. And then I will separate them into integral of x dx plus integral of dx minus integral of 3 over x dx. Once I have this, I get x squared over 2 plus c1 plus x plus c2 minus And I should have taken 3 out of the integral sign before, but I will do that now, and I get 3 ln of x plus c3. And now I will combine all the constants together and change them into just 1c, and I get x squared over 2 plus x minus 3 ln of x plus c as my final answer. Okay, for this question over here, I have to find the derivative of x squared minus 4x plus 10 over x squared square root of x with respect to dx. So what I will do first is actually write this denominator in terms of exponents, so in exponent form. So I get x2 times x to the 1 over 2, and if I add their exponents, I will get x 4 over 2 plus 1 over 2, which is 5 over 2. And that's my starting point here. What I will do next is write this a little bit simplified form. X squared over x 5 over 2 minus 4 x over x 5 over 2 plus 10 over x 5 over 2 dx. And I gotta make sure that I put it in brackets. Next, I will simplify the exponents. For the very first one over here, I get exponent 2 minus 5 over 2. This is same as 4 over 2 minus 5 over 2, which becomes x to the negative 1 over 2. Forgot my equal sign there. Equals integral of x negative 1 over 2 for my first one minus 4. And here I got x to the exponent 2 over 2 minus 5 over 2, which gives me negative 3 over 2. And finally, for the very last one, I get 10. And all I'm doing is I'm bringing the denominator to the numerator. The exponent changes from positive to negative, and I'm left with x to the negative 5 over 2. Next thing I will do is separate all of these, and I get x to the negative 1 over 2 dx minus 4 x to the negative 3 over 2 dx plus 10 integral of x to the negative 5 over 2 dx. And once I have this, what I have done is I have brought the constants out of the integral so that my integration becomes a little bit easier. So now I add 1 to my exponent and I divide by that value. So here I'm adding 2 over 2, so it becomes x to the 1 over 2 over 1 over 2 plus c1 minus 4 and negative 3 over 2 plus 2 over 2 becomes x negative 1 over 2, and I have to divide that by negative 1 over 2 plus my second constant, and the constant is also multiplied by 4, but since it's a constant and we don't know its value at the time, we can just leave it at as c2. And finally I get plus 10 x, negative 5 over 2 plus 1 is negative 3 over 2. I have to divide that by negative 3 over 2 and add my final constant. Let's simplify a little bit. So here I have 1 over 2, the 2 moves up here, the 1 is just in the denominator, so I will leave it as is. And what I will do next is also combine all the constants into 1c. So first I get 2x 1 over 2 minus, divided by minus gives me plus 4 times 2 gives me 8, x to the negative 1 over 2. And then I get positive multiplied by a negative gives me a negative. 10 times 2 gives me 20 over 3, x negative 3 over 2. And I'm just adding one constant instead of all the constants here. So you can leave this as the way it is, or you can change forms if you want and change it back to radicals if you wish, but this is your final answer in exponent form. This question asks us to determine the integral of 2et minus 4 sine t with respect to dt, or with respect to t. And this is a little bit more exciting because we've always been dealing with x and now we're dealing with t, which represents time. So in terms of mathematics, it's very similar to everything else. First thing I'm going to do is separate all the constant from the integral sign and also separate the two terms from each other. So this will equal to 2 integral of et dt minus 4 integral of sine t dt. So now I get 2 integral of et is just et plus my first constant minus 4, and I have sine t, which is cos t, its integral, or negative cos t actually, to be more precise, or more accurate, plus c2. And finally what I will do is I will write this as 2et. I want to combine all the constants, so then I get negative times a negative, which positive 4 cos t, and I will just leave the final answer with 1c, and I get 2et plus 4 cos t plus c. Okay, for this questions it says determine function y if dy by dx is equal to 1 over x squared first. So here what I can do is I can multiply both sides by dx. So multiply this side by dx, multiply this side by dx, and that kind of removes the dx's here, and I'm left with dy is equal to 1 over x squared dx. So then what I will do, I will take the integral of both sides, and integral of left side here is integral of dy with integral of 1 with respect to dy, which will just give me y plus c, or constant 1. And on this side I have integral of 1 over x2. 1 over x2 is same as x to the exponent negative 2, so I have to add 1 to the exponent, so I get x to the negative 1 divided by negative 1 plus a constant 2. So then I get y plus c1 is equal to negative x to the negative 1 plus c2. Now I will, by subtracting c1 from both sides, these two will just become one constant value, and I remove the c1 from here. So I get y is equal to negative, and x to the negative 1 is same as writing 1 over x plus some constant value, and that is my final solution. For this question I will do the exact same steps. First thing I will do is multiply both sides by dx. And I will get dy is equal to square root of x minus, actually let's write this in terms in exponent forms instead. So it becomes x to the 1 over 2 minus 2x to the negative 1 over 2 here, dx, both in brackets, and I will take the integral of both sides. So the left side is integral, left side here is integral of 1 with respect to dy, or just constant with respect to dy, and that constant value is just 1. So the left side is easy, just becomes y plus c1. And the right side, I actually have to separate it. So I'm going to do this in 2 steps. I'm going to find this, I'm going to change this to integral of x to the 1 over 2 dx minus 2 integral of x to the negative 1 over 2 dx. And once I have this, I'm going to integrate, so I get y plus c1 is equal to x to the 3 over 2 over 3 over 2 plus c2, another constant, minus 2 times the integral of x to the negative 1 over 2, which becomes x to the 1 over 2 over 1 over 2, plus my third constant. I'm going to simplify a little bit, so I get y is equal to 2 over 3x 3 over 2 minus 4x to the 1 over 2. And this constants here, I will move them all to the right side of the equation, and I will change them to one constant instead, and I will just write that as plus c for my final answer. Okay, the next question says determine f of x given that f prime of x, or the derivative of f of x, is equal to e to the x plus 1 over square root of x, and we're also given that the function at x value of 1 is equal to 1. So first I have to find the function, and I will do that by finding the integral of f prime of x. So I can write that f of x is equal to integral of e to the x plus x to the negative 1 over 2 dx. And that becomes integral of e to the x dx plus integral of x to the negative 1 over 2 dx. And that simply becomes e to the x plus, I'm adding 1 to the exponent here, so I get x to the 1 over 2 over 1 over 2 plus some constant value. So I've combined both constants together in one step here, and I get e to the x plus 2x 1 over 2 plus c as my final integral here. So now I have to use the information that I have to find my c value. So I have the function value at x is equal to 1. So I know that f of 1 is equal to 1, and that is equal to e to the 1, which is just e, plus 2 times 1 to the exponent 1 over 2, which is just 1. So I'll leave this as 2, plus c, meaning that c is equal to 1 minus 2 minus e, which is equal to negative 1 minus e. And once I have this, I can write that my final function f of x is equal to e to the exponent x plus 2x to the exponent 1 over 2 plus my c value, but luckily now I have my c value, and that c value is equal to negative 1 minus e. My second function is more of a trig function, so I have f prime of x is equal to 2 cos x minus 3 sine x, and I'm given that f at an x value of pi over 4 is equal to 1 over square root of 2. So the first thing I have to do again is to find the integral of f prime of x to find my function. So f of x can be written as the integral of 2 cos x minus 3 sine x with respect to x. So let's separate things. So I get 2 integral of cos x minus 3 integral of sine x. Forgot my dx, so I will actually erase this. Dx here minus 3 integral sine x dx. So now integral of cos x is sine x, so I have 2 sine x plus my first constant minus 3 times negative cos x, which is the integral of sine x, plus my second constant, and simplify a little bit and I get 2 sine x plus 3 cos x plus 1 constant value instead of c1 and c2. Okay, so now I know that at f pi over 4, at x value of pi over 4, my value is 1 over square root of 2, and that is equal to 2 sine pi over 4 plus 3 cos pi over 4 plus c. Now, on the side, if we use our special triangles really quickly, I get 1 square root of 2 pi over 4. So cosine is cosine is adjacent over hypotenuse, so that's 1 over square root of 2, and sine is opposite over hypotenuse, so then I get the same thing for both cases. So to solve for c, I know that 1 over square root of 2 is equal to 2 times 1 over square root of 2 plus 3 times 1 over square root of 2 plus c. So I get 5 over square root of 2 plus c here. So then I get c is equal to 1 over square root of 2 minus 5 over square root of 2, which is equal to negative 4 over square root of 2. So now I know that c is equal to negative 4 over square root of 2. I can simplify this by multiplying by square root of 2, square root of 2, and I get negative 4 square root of 2 over 2, which is equal to negative 2 square root of 2. And I can leave my final answer as f of x is equal to 2 sine x plus 3 cos x plus my c value, and my c value is minus 2 square root of 2. Okay, the final example that we will do is this question over here, which says determine f of x given that f double prime of x is equal to 2x and the points 1, 0 and 0, 5 lie on the curve. So the first thing we have to do is find our f prime of x. So f prime of x is equal to integral of 2x with respect to dx and that just becomes 2x squared over 2 plus some constant value. So to simplify that, I get x squared plus c, and that value is my, that function is my derivative. Now the question actually wants us to find f of x, and we have f prime of x, and the information that we're given about the question is also has to do with f of x and not f prime of x. So the next thing we have to do is find f of x. So f of x will equal to the integral of f prime of x with respect to x. So that will become x squared plus c. And I don't know what my c value is. I know it's a constant. So I'll write it like this, and it becomes x squared dx plus c integral of dx. And now I get x cubed over 3. And my constant here, I will get another constant. I will use the letter d here so that I don't confuse the first constant and the second constant. Because this constant here, the d value, has to do with the f of x, whereas the c, the constant c, had to do with f prime of x. So I can label this as d1, and then I get plus c, and the integral of d of x is just x, and I get d2 as the constant for this integral. So d1 is constant for this, d2 is constant for this, and if you remember again, c is the constant over here. Now d1 and d2 are both just one constant value, so I can simplify this to x cubed over 3 plus cx plus d. If you notice now, I have the function and I have two unknowns. I don't know what this c constant is, and I don't know what this d constant is. And I'm given two different points, so I will have, I can make two equations, and I have two unknowns, and I can solve for those. So let's do that next. So I know that f of 1 is equal to x, well, instead of x I will plug in 1 cubed over 3 plus c times 1 plus d, which is equal to 1 over 3 plus c plus d. And I know that this is equal to a value of 0. So that's using this point over here. Now I will use my second point over here. So I know that at f of 0, I get 0 cubed over 3 plus c times 0 plus d. So I pretty much get 0 plus 0 plus d. And I know that f of 0 is equal to 5, meaning that d is equal to 5. And since I have d, I can plug that into this equation over here. So this is, let's say this is equation 1, this is equation 2, sub 1 into 2, and I will get 1 over 3 plus c plus 5 is equal to 0, so c is equal to negative 5 minus 1 over 3, which is equal to negative 16 over 3. So finally I can write my final equation, and my final equation is right here, x cubed over 3 plus c value, which I found right here as negative 16 over 3, x, plus my d value, which is right here, and it's written as 5. So I can write my f of x as x cubed over 3, my c value, which is negative 16 over 3, x, plus my d value, which is 5, and that is my final answer.